Good morning, welcome to Wednesday's Maths. Today is the 20th of January and your skill today is to add fractions with related denominators. Now I do hope you're not feeling like this today, although it is Wednesday, but get today over and done with and you've only got 2 days left. Okay. Oh, I forgot to mention yesterday as well about the beeping. Did you notice the beeping had stopped? We have no beep. So when I said about getting new fire alarms, it happened. It happened on the day I said it was going to, which I was impressed with. Yes, we've got no more beeping now. So no more parrot noises, luckily for you. Not that I really heard it because I get used to it, but yeah, no more beeps. Okay, so make sure you have underlined your date and skill, and then you can start your arithmetic. So your arithmetic today is your your squared numbers for your bronze challenge. Your silver challenge, you're looking at sequencing. Now I do apologise, a couple of the arithmetic questions on the video yesterday were incorrect. Okay, I made a couple of mistakes, obviously rushing too quickly, trying to get it done for you, and didn't quite check my work, which we should always be doing. Okay, but I did notice after I'd recorded the video, so the correct version was on the website for you under the resources and the attachments, but it was too late by the time I'd recorded the video to change it, because I can't change it once it's been recorded. Okay, so I do apologise, but hopefully today they're all correct. Okay, so you just need to find the next two numbers in each sequence there. And then your goal challenge is finding and ordering these numbers in ascending order. Okay, I thought we'd have a recap of this because we haven't done this for a while, and it's a good skill to know. So remember that ascending was going up and descending like down the stairs. So these are going from smallest to biggest. So order those, really check your place value knowledge. Brilliant. And here are your answers, okay? So make sure that you've answered all the ones that you've ticked, all the ones that you've got right. Make sure you're not times in by 2 for these squared numbers. So many people still times by 2. It's just a number times by itself. The 2 is there just to trick you. Okay, so today then, so let's find the equivalent fractions just as a recap. So remembering to find equivalent fractions, the denominator needs to be the same. Okay. So what are we going to do? You've got 3/4 equals something eighths. How are we going to do that? Okay, so hopefully you'd remember that you are going to times the 4 by 2 to get 8. Which means you're also going to do the same to the numerator. So you're going to times that by 2 to get 6. So 3/4 is equivalent to 6/8. Okay, next one. You've got 5/15 and you've got something over 3. How are you going to do this? Okay, so we can see that we have times 3 by something to get to 15. Or divided 15 by something to get 3, so that's obviously 5. Okay, so if we divide 5 by 5, we're going to have 1. So it's equivalent, 1/3 is equivalent to 5/15. 9/6 then, so this is an improper fraction, so the numerator is larger than the denominator, is the same as something over 12. Now we've times 6 by 2 to get 12. So if we times 9 by 2, we're going to have 18. And then lastly, we have 2 and 6/8. So this is our mixed number. It's the same as 3 over what? Okay, so we've divided the 6 by 2 to get 3. We can divide the 8 by 2 to get 4. Okay, good effort, well done. This time I'd like you to compare these fractions using greater than, less than or equal to. Okay, so you'll need to find the equivalent fractions again to do these perhaps. Okay, so have a go. Of course, pause the video if you need more time. Okay, so let's go through the answers. So 3/4, is it greater than, less than or equal to? It's greater than, because if we're timesing the denominator by 2 to get 8, and then we times the numerator by 2, it gives us 6, it'll be 6/8. So that's bigger than 2/8. Then we've got 2/3 is greater than, less than, equal to 5/15. Okay, we've times the 3 by 5 to get 15. If we times the 2 by 5, we'd have 10. So it's greater, 10/15 is greater than 5/15. And then we have 9/6 and 20/12. So which is larger? 20/12 is greater than 9/6. So 9/6, if we convert it to the equivalent fraction, okay, would be 18/12. Okay, so improper. So it's less than 20/12. And then 1 and 2/8, is it greater than, less than, equal to 1 and 1/4? It's equal to, it's the same. Okay, so we've got 1 and 2/8 is the same as 1 and 1/4. Marvellous. Okay, so if you got those correct and you're able to do those, it's really going to help you out today. So good thinking. Let's have a look. Anna and Bart want to share this chocolate bar. Bart says, I'll have 4/9. You can have the rest. Anna says, well, what fraction of the chocolate bar will I get? Have a think. Have a talk to your partner or the people around you. Okay, perhaps you want to even try it. Mrs. Coleman's very naughty. Mrs. Coleman's got a chocolate bar. Other brands are available. And if I here we go. I've got 9 pieces of chocolate, just like the one on the screen. Bart says he'll have 4/9. So Bart's going to have 4 of the pieces. Maybe Mrs. Coleman could be Bart. So Bart's going to have 4/9. Oh no, this isn't a great job. Okay, so this is Bart's 4/9. Okay, how many pieces are left? What fraction will Anna get? We know that 1 whole is 9/9. Okay, this is 9/9. But got 4/9. How much will Anna get? So 4/9, add the 5/9 is 9/9, is 1 whole. Okay, all I can smell now is chocolate and I really want to eat it. So we've got 1 whole, okay? So we had 4/9, add 5/9 equals 9/9. Now, it's important that to solve the calculation you have to keep the denominator the same. It's only the numerators that are different, okay? So 4/9 add 5/9 is 9/9 because we've still got the whole amount. Okay, let's try this one. I haven't got any cakes, I'm afraid. So Anna says, I would like 6 of the cakes to share with my family. Bart says, well, how many will be left for my family? So what fraction is Anna going to get and what fraction is Bart going to get? Let's have a look closely. So we know that Anna would like 6 of the cakes to share with her family. 6 cakes out of how many? How many cakes have we got all together? Okay, so we've got 12 cakes all together. Okay, so we know that Anna would like 6 out of the 12 cakes. Okay, and we know that our whole number is 12 because we've got 12 out of 12 cakes is one whole number. So if Anna wants 6 out of the 12, how many is Bart going to get? Hopefully you'd realise that Bart is also going to get 6 out of 12. So they're going to get half each, okay? So half the amount of cake. So we could simplify that to 1 over 2. Okay, because both numbers can be divided by the same number. Okay, can both be divided by 6. Sorry, I'm just trying to get chocolate off my laptop now. Okay, so Bart will also get 6/12. So it's the same as 1/2, because if we divide them both by 6, 12 divided by 6 is 2, 6 divided by 6 is 1. Let's try this one. Henry and Ella have the same size chocolate bar. Henry eats 3/5 of his chocolate bar. Ella eats 4/5 of her chocolate bar. Who eats the most chocolate? How much do they eat all together? Okay, so who eats the most chocolate? Let's look at that one first. Who eats the most? So if Henry's going to eat 3/5 of his chocolate bar, Ella's going to eat 4/5 of her chocolate bar, the denominator's the same, which means Ella eats the most chocolate. Okay, the denominator the same, so we just look at the numerator to see who ate the most. If you remember, if we were colouring it in, we'd be colouring in 4 out of the 5 parts for Ella, 3 out of the 5 parts for Henry. If this was on a bar model, okay? It's the same for the chocolate. So Ella eats more. But how much chocolate did they eat all together? It's a little bit different, this one, isn't it? Because we keep the denominators the same. Okay, but we just need to add the top numbers together. So if Henry eats 3/5 and Ella eats 4/5, how much do they eat all together? They eat 7/5. How can we do this now? What do we need to do next? We've got an improper fraction. We need to change it into a mixed number. Okay, so how many 5s go into 7? We've got 1 whole and 2/5, because it goes into 7 once and there's 2 left over. So they ate 1 whole chocolate bar and 2/5 of a chocolate bar all together. Okay. Brilliant. So now it's your turn. A quick independent practice before we carry on with our learning. So can you write these fractions in your books and calculate the answers for me? So you've got 3/5 add 1/5, 6/8 add 2/8, and 5/3, so 5/3 over 5, plus 5/3. Okay, have a go at those. You may need to convert them into improper fractions and mixed numbers. Okay, see how you get on. So pause the video now and come back when you're ready. Okay, so 3/5 add 1/5. Okay, easy peasy, 4/5. We're just adding across the top, the denominator stays the same. So now we've got 6/8 add 2/8. So it's 8/8, which also makes 1 whole. Okay, so that's 1 whole, 8/8 is the same as 1. And then we've got 5/3 plus 5/3, which equals 10/3. How are we going to write that? Okay, 10/3 is the same. How many times does 3 go into 10? Is 3 with 1 left over. 3 times 3 is 9, plus 1 is 10. Great job. Okay, we're going to start getting a little bit trickier now. So, Emma eats 2/4 of a pizza, but Mary eats 4/8. We've got Emma's pizza on the left, Mary's pizza on the right. Talk to your partner. Is it possible to add 2 fractions with different denominators? a think, have a chat. If you're at home, try and work it out. Okay, do you think it's possible? What do you think? What do you think you might need to do? Pause the video, come back when you're ready. Okay, so it is possible. However, we need to convert the fractions into equivalent fractions so they have the same denominator. It makes it a lot easier to be able to work it out and calculate, okay? So if we see here, we've got Emma eats 2/4 of a pizza, so 2/4. But Mary eats 4/8. So we need to make sure the denominators are the same. So we need to convert 2/4 into 8ths. Now we can times 4 by 2 to get 8. So then we need to times our numerator by 2, which is 4. So now we know that Emma has eaten 4/8 of pizza. Oh, and Mary's also eaten 4/8 of pizza. So altogether, they've eaten 8/8, which is the same as 1 whole. Now the image of the pizzas up here shows us that as well, because we can see that Mary's eaten half a pizza and Emma's eaten half a pizza. Okay, so together they've eaten 1 whole. Maybe I should have got some pizzas as well, so I could have had pizzas, chocolate, cakes. I could have eaten all this food just to show you fractions. How marvellous would that have been? Okay, I probably would have also felt very poorly. So, Hayley has eaten 2/3 of her sweets and Keely has eaten 2/12. Calculate how many sweets have been eaten together, altogether. Okay, so what do we need to do this time? Okay, so we've got 2/3 and 2/12. We can't do that because we need to convert it into an equivalent fraction. So, we know that we can times 3 by 4 to get 12, which means we need to times 2 by 4, because if we times the denominator, we need to do the same for the numerator. So we can see we've got 8/12. We can now add this to Keely's 2/12. So 8/12 and 2/12 equals 10/12. Okay, we can simplify this because both of these numbers can be divided. Okay, so we've got 10/12. If we divide them both by 2, we've got 5/6. That is the smallest fraction we can make. Okay. So whatever you can divide your total fraction by, your whole fraction at the end, your final fraction of your any calculation, if you can divide both numbers by the same thing, you can simplify it, you can make it smaller. Okay. Let's have a guided practice then. So this time we're going to do the same, but I would like you to do it with me. So we're going to calculate 1/5 and 1/10. So, step 1, make sure the denominators are the same. How are we going to do that? Okay, we've got 1/5 plus 1/10. We need to change the 1/5 into tenths. Okay, so we can times that by 2. So over here now, this is our new sum. So we've now got something over 10 plus something over 10. Our denominators are the same. But because we timed our 5 by 2, we now need to times our 1 by 2. Okay, so 2 times 1 is 2. Step 1, done. Step 2, add the numerators together, making sure the denominators remain the same. Okay, so we've got 2/10 plus 1/10, which is 3/10. So we haven't changed our denominator, that stays the same, we've just added along the top. Okay, you've now got some independent practices, okay? Now, there is a mild, a spicy and a hot. Choose the one that you feel comfortable with. Okay, you might want to do all 3, that's completely up to you. If you want to do mild, you can pause the video now. If you want to do spicy, you can pause the video now. And if you want hot, you can pause the video now. Of course, you can go back if you decide to do hot and you think, actually, this is a little bit too tricky. I'm going to go back, just rewind it and then pause it there. Okay, so think about what we've been doing in this session. Rewind the video to go over things, but you just really need to make sure you're converting those fractions so they have the same denominator to enable you to add them together. Okay. And your final thought then. So your final thought today is to find the missing numbers. How would you go about this? So our total is 15 out of 16, which gives us a really good inclination that this here needs to be 16 if they've been added. So we've got 16 here and we've got 8 here, so we know that we can times it by 2. Okay, so if we're timesing 8 by 2, that gives us 16 here, but oh dear, we don't know what we're timesing by 2 up here. However, what we do know is that we've got 15. If we take away the 5 from our 15, it leaves us with 10. Okay, so does that work? Well, it can't be 10 times by 2 because that would be too many. Okay, so we can, if we have this one here, 5/16, we know that it will be 5 here because we're timesing 8 by 2 to get 16, and we times 5 by 2 to get 10. 10 add 5 is 15. And then you've got the bottom one. Okay, so you've got 3/20. Sorry, I didn't realise that was going to come at the same time. It was supposed to come up afterwards. Okay, but you gave you a good idea for the first one. So we have 17/20. Okay, so if we know we're timesing this one by 2, we need to times this one by 2. So that's going to be 14/20, which means we need to add on 3 more. Okay, well done at having a go at that if you did. Okay, finally then, here are your answers. Okay, I'm not going to read them all through because you can just pause the screen as you like. However, some of them do have simplified answers, so you just need to double check. Okay, so here are your mild answers. So we've got 9/10, 4/3, so that's an improper fraction, that one. So you could convert that to a mixed fraction, so it'd be 1 1/3. Okay, and then you've got 3/3, which is the same as 1 whole. You've got 9/10, 12/8. Again, you can convert that. Okay, so 8 can go into 12 one time with 4 left over. And then you've got 6/12, which can be simplified again into 1/2. Spicy. So 8/10 plus 1/2 is 1 3/10. 5/3 plus 11/15 is 2 6/15. 2/3 plus 7/12 is 1 1/4. 7/10 at 4/5 is 1 1/2. 7/8 at 3/4 is 1 5/8. And 5/12 plus 3/4 is 1 1/6. If you've got a slightly different answer, it might just mean that you haven't simplified it. So see if you can divide it any more than you already have. Okay, your final answer. Okay, so hot. I said I wasn't going to read these out, didn't I? But I kind of did. So 8/14 add 1/7 is 10/14, which can be simplified to 5/7. 5/24 add 1/6 is 9/24. okay, which can be divided by 3 to give you 3/8. 1/3 plus 7/12 is 11/12. And you've got 15/18, which can be simplified to 5/6. 1 3/16, and 1 1/24. Okay, super learning today, guys. I hope you found those okay. Okay, enjoy the rest of your morning. I shall see you this afternoon for PE. Okay, so have a great morning. Enjoy your English as well, and I shall see you later.